Hello and welcome to another episode. Today we learn about artificial intelligence from somebody that really knows their stuff. His name is Anudeep, and Anudeep is the founder of a deep tech AI startup called Cybrain. He's also a Yale graduate with tons of experience in the space. He's a computer scientist, blogger, philosopher part time, and one of the most curious people I've ever met. And in this episode, we discuss about everything AI, why the technology is progressing so quickly, how it works, the risks associated with it, the hypocrisy of OpenAI, leveraging AI's potential for yourself, and so much more. And without further ado, here is Anudeep. How has artificial intelligence evolved over the years? Can you give me a brief about the history?
So, artificial intelligence, the big changes that you're seeing right now, isn't any new algorithm or any new math that's going behind it. The reason that you're seeing this is because of two changes. One is a massive increase in the computational power that we are able to muster thanks to GPUs and like really much faster CPUs. And the second thing is how we have architected the math around how these neural nets are trained. So those are the two big things that has caused like all of the recent like crazy growth in artificial intelligence. But if you go back to where it started, uh, one of the first implementations of an artificial intelligence, so to say, was by a guy called Frank Rosenblatt. He created this single neuron called a perceptron. And essentially, what he was trying to do, if I remember correctly, was he was trying to distinguish between images. And he was trying to do this in a way where he wasn't telling the computer what to do, but the computer would be able to figure out by itself what it was doing. And he used how the human eye works as an example to kind of architect the system. So the way that he did this was he essentially created a big circuit board of um, like a big circuit board and like connected wires to every single point on it, and then gave the system examples of what it could do or what was correct, what was actually what we today call labeled images, and over many cycles it slowly gave it an algorithm to slowly tune its weights so that it kind of got closer to what the right answer was. So this is a very basic implementation of a neuron, but amazingly it kind of worked. And he maybe would have done a lot more, but I believe, if I'm not wrong, Frank Rosenblatt died at a very young age, like around 35-40 years old. But that was like one of the first artificial intelligence neural nets, so to say. And if you take like one step even before, the first implementation or first thought of like what a neural net or what a neuron does came when we discovered how the neuron in a cat retina works. One of the first implementations was to understand that a neuron is essentially like connected to other neurons, and based on the input, it decides whether to fire or not to fire. So we kind of understood that by observing and looking into the neuron in a cat brain. And that led to the thought, oh, if this is what it does, could we not simulate this mathematically? And that was one of the first thought of like, okay, this is what a neuron could do. Frank Rosenblatt then actually built a machine around it, and um, after that, so that was the implementation of a single neuron you could think of. Then the thought came, okay, what would happen if we start layering neurons one after the other? You could do more interesting things. But a big problem during all of this was, how do you train a neural net? Like, okay, like the architecture kind of looks similar to how the human brain works, but how do you actually train it? Because we don't understand how we train our brain. So in around maybe I'm a little off with the time frame, but the late 80s or the early 90s, um, a group of researchers came up with the backpropagation algorithm. Now, the backpropagation algorithm is very fundamental to all neural nets, and what it does is it basically is an algorithm that tells a long neural net that if this is the right output, how do you propagate the error backward? So that if you propagate the error backward, then each neuron knows how much to correct itself by. This sounds very simple, but it's the algorithm is not very complicated, but the fact that we were able to come up with is pretty cool. And these two innovations, which is okay, a neuron is a weighted sum of inputs, and two, you can, based on the right output, you can propagate the error backwards, and then each neuron can figure out how much to correct itself by. These two innovations were responsible for a lot of like the crazy growth in artificial intelligence.
Right. And could you explain a little bit, in very simple terms, like how do modern AIs work for the mass audience that doesn't know anything about them?
So what they're doing is, so we talked about what a neuron does, right? A
Hmm.
neuron basically takes a weighted sum of inputs. So if there are two inputs to a neuron, then each input has its own weight associated with it. Then you do a weighted sum, and if that weighted sum is above a certain value, the neuron fires. If it is below that certain value, it does not fire.
Hmm.
Okay, that's what a neuron does. That's what a mathematical or an artificial neuron does. Now, the really cool thing about this is if you take this simple thing and you structure them into layers, they start understanding language. If you start putting them into sheets, they start understanding images. And if you start putting them into cubes, they start understanding video. So, at the very base of this is a neuron. All it does is it's a weighted sum of inputs. And then if that weighted sum is above a certain value, the neuron fires. If it is below it, it doesn't fire. That's the fundamental concept. Now, what enables the modern artificial intelligence nets to do their thing is the implementation of attention. So, what the modern neural nets are trained on is if, let's say, I say a sentence like, my name, I live in China and my name is Dash. Okay?
Hmm.
Like, let's say that is the sentence. Now, what a neural net is trained to do is take all of the symbols that have come before the dash and use that as the context to predict what the next word should be. So here you could look at all of the words and say, okay, I live in China and my name is. So here you could get a sense that, okay, what you're supposed to output is a name.
Hmm.
But what would be even more interesting is if you could look at all of the past symbols and see which ones are more important in figuring out what the fill in the blank is. So here, for example, I know that I'm saying I live in China and my name is. So the neural net somehow is able to implement attention, which is it's able to look at all of those symbols and understand, okay, the word attention and the word China, sorry, the word name and the word China are more important than the other pieces. So the name that it comes up with is not just some random name, but a Chinese sounding name, because both of those kind of are like put together. Um,
Okay. Okay, it's like a
so
logical sequence where.
yeah,
Okay.
but like previously, like it used to place equal importance to every token that came before it. But now the
Right.
modern nets are able to implement attention, which is they by themselves are able to understand which words in that sequence are more important versus less important and use that to predict the next word and then the next word and then the next word. So, like ultimately, what it is doing is it's predicting one word at a time and it's an auto regressive model. So it predicts one word and then runs that whole thing again and then predicts the next word.
That's so interesting. It's like I don't know if this example like fits into this picture, but correct me if I'm wrong. It's like let's say there's a massive spider web, okay, multiple spider webs just connected together, and then you drop a ball, okay, on one of the spider webs. Now it goes down onto a specific point, and then from that weightage, it connects to another one, where another ball drop, and then it's kind of connect somehow, but it's
Yes.
that weightage
Yes.
is a complicated. Um, way to sort of think about these things because we don't really perceive language as that.
Yes.
And I guess to put it in simpler terms as well, like uh, let's use the analogy of a human being, okay? And how is a machine able to think like a human being? Like just to narrow down what we've discussed a little bit.
So that's a very interesting question because the way that the people who have come up with the GPT-3, the Chat GPTs of the world, the way that they propose thinking about the artificial intelligence is that it is an alien intelligence.
Hmm.
It functions in a different way than we do as humans, but still it is intelligence. Um, and by doing this, you're essentially maybe trying to create like a separation between okay, this is human intelligence and this is artificial intelligence.
Hmm. Hmm.
But how artificial intelligence and human intelligence are different is a very complex question because what we do as biological organisms is the template for what we are uh, innovating with on artificial intelligence. So like we couldn't have come up with we couldn't have come up with artificial intelligence without having first access to the human brain and understanding how the human brain works and then using that as a template to do this, right? So you could
Hmm.
in one way think that if the human brain or the human intelligence is like a 100 dimensional thing,
Hmm.
maybe artificial intelligence is a single dimensional thing at this point.
Hmm.
In the
Right.
future, maybe the number of dimensions can increase. But a crucial difference is that we formulate, so when human beings are born, we are not born intelligent. We're born with pretty much an empty brain,
Hmm.
with very few things embedded within us. And this is quite different from how like other animals like cats and dogs are born. Cats and dogs are born, and then within 2 to 3 months, their parents, like the cat mom or the dog mom, like they take like 2 to 3 months of time to fine tune the animal onto their surroundings, and after that, they're good to like live independently. Human beings are not like that. We take 18 years to kind of be able to start living independently, right?
Hmm.
And the reason is because when we are born, our brains are fairly empty
Hmm.
in terms of content.
Hmm.
Um, it is the experiences that we go through in the real world that form our brain, so to say. And when I
Right.
say form our brain, what I mean is due to some genetic predispositions that I may have, okay, and due to the environment that I am surrounded in, my family life,
Hmm.
my friends' life, where I'm living, and all of that, due to the culture that is around me, there are differences to what I pay attention to in what happens to me. Like,
Hmm.
of the things that are happening to me, there are certain things that I pay more attention to versus somebody else maybe like you, right?
Hmm.
And those differences is what encodes kind of intelligence into the brain.
Right.
Um, and it is those differences that make us unique. We're not
Yeah.
born intelligent. We kind of like fine tune on the universe around us. And the way we update also is only through action. So, like when we do something, the brain kind of like it's constantly self correcting. And it is that constant self correction that we kind of learn from. Whereas the way that artificial intelligence is built, at least for now, is it is trained on a vast amount of data, truly vast amount of data, but then it is kind of stuck in that. After that, it's like, okay, this is the intelligence that I have, and I'm going to use that to like predict things, like as like whatever you give it to me as an input, I'll use this knowledge that I have and try to tell you what I think the answer could be. It isn't self-correcting. And part of the reason it isn't self-correcting is because it is out of touch with reality, right? It's only connect with reality is the data that human beings have created. So it does not know what reality is. We, as of now at least, we are the only beings that are in touch with reality and also in touch with the symbolic universe that we call language. Whereas
Uh,
an AI is
That's
only connected to the language.
that's interesting, because I'm curious where the distinction between what's imagined in language, um, like, sorry, the symbolic representation and versus the biological one, let's say, is what you're the distinguish. I'm just curious, like how you can tell how a machine can tell the difference in language, because language is also like a symbolic representation of the world,
Yeah, yeah,
and even to represent ideas, that's a quite a but okay, but uh, going on to another related question though, um, if how is it able to reason through abstract, the seemingly abstract questions then, because an AI can do that, and Chat GPT, at least the latest version as well, can has enhanced reasoning capabilities.
yeah.
How is this related? How is it able to do that? Like how is that related to this as well?
So, so the point that we made previously about the symbolic universe and the non-symbolic universe
Hmm.
is is relevant here.
Hmm.
And so, how do you differentiate between? So, biology is real, whereas the thing that Chat GPT and all of that do for now is symbolic. So, in mathematics, there is something called the Platonic world and the real world. So, Platonic world is where perfect things exist, like a perfect
Hmm.
sphere. Okay,
Hmm.
there's a way to draw a perfect sphere, right?
Hmm.
Um, does a perfect sphere or a perfect circle exist in the real world?
Hmm.
It doesn't. Does
No.
a perfect line exist in the real world? It doesn't. Does a perfect square exist? No. Perfect rectangle? No. Triangle, cone, pyramid, all of these are symbolic representations of things that's like a collection of ideas from different things.
Hmm.
And it is a system that we have created. And somebody famous said, all systems are wrong, some are useful. And so this is
Hmm.
like a system that is useful. So even though a real circle or real sphere does not exist, and you could look at the sun and say, oh, but the sun is a sphere. No, it's not. It's really not a sphere, right?
Hmm.
The more you zoom in, the more it is completely undulated. There's like solar flares that are coming out. So it's not a sphere, even though from far away it does look like one.
Hmm.
So So that's the symbolic representation. So, like, language is a symbolic representation of the universe because we may be incapable of taking the world in its entirety.
Hmm.
So, but we're still able to live and function, right? We're able to have a conversation, we're able to do things, we're able to manipulate the universe, and to the point that we could be considered as a virus on the planet Earth. We could be. I
Hmm.
don't think we are, but we could be. To the point that we have shifted the ecological climate to the point that global warming is a serious problem, right? So even though we comprehend the universe only symbolically, we are still
Hmm.
able to use that system to affect the real world,
Hmm. Hmm.
right? So what we are then doing is you could make a point that every thought I have, okay, everything that I'm saying, what I'm doing is I have a context in my brain. You could
Hmm.
call my ego the context that I always keep active.
Hmm.
Okay. And whenever I'm saying something, whenever I'm having a thought, it is a function of all of the previous context that I have strung together, and I'm saying, okay, based on this, what is the next thought? And I'm constantly doing that,
Right.
right? And that's what Chat GPT is doing.
Hmm.
So even though it's a very simple task, so to give you a little bit more of a background, the things like GPT and Chat GPT, the language models that they're based on, they're trained on a very simple task. It's called masked language modeling.
Hmm.
So in masked language modeling, what you do is you take vast amounts of text, you pass it through a neural net, and then you mask 15% of the words.
Hmm.
And then you ask the neural net to guess what is the word that you expect to be in that blank.
Hmm.
It then comes up with a prediction, and then you tell it, no, actually, it is this word. And then it corrects a little
Right.
bit. And then you keep doing that again and again and again over incredibly vast number of times, over incredibly vast amount of text.
Hmm.
And then when you do that, it starts understanding the distribution, the statistical distribution representation of language. And
Hmm.
this intuitively makes sense because I'm sure you must have experienced this when you're reading a book and you come
Hmm.
up with a word that you don't understand. Like you don't understand the definition of it, but you're able to
Yeah.
guess the meaning based on the words around
Right.
it. Right?
Yeah.
So that's what this has been trained on. So the cool
Right.
thing is, if you take that as a basic, like just that as like the fundamental first principle, and then you like keep adding on that, maybe something as
Hmm.
complex as human intelligence emerges. So the reason that a chat GPT is able to reason abstractly is because maybe at the very base of things, that is what we do. We have a
Hmm.
context, and then using that context, we predict the next word, take
Right.
it to one level higher complexity. Based on the context of thoughts we have had, we predict the next thought. Take it one level further, based on the context of experiences we've had, we predict the next
Okay.
experience.
That's fascinating. And as you build off of this, like more and more and more, it can not only guess the word, but it can also formulate the entire sentences in a much more robust way based off of
Yeah,
the question on
yeah,
various parameters like truthfulness.
yes.
And
So truth is hard. So what is truth?
hmm,
Truth is
hmm,
something we all have a symbolic representation, right? We cannot comprehend the universe in its entirety. So we have a symbolic representation. Truth
hmm,
is a symbolic representation that is as aligned as humanly possible to reality,
hmm,
right? And that is also like a growing, like it's not like a perfect situation. Like the more data you get about the real universe, um, the more you need to like push towards truth as well, right?
hmm,
So truth is an alignment between the symbolic universe and the actual universe. Chat
hmm,
GPT and GPT and language models exist only in the symbolic universe. So they are
hmm,
untethered to reality. So they do not understand truth. That is why we need humans, because humans are the people, at least for now, who exist in both these realms. And so
hmm.
they are the ones who are able to tell ChatGPT when it is being trained, hey, this is what of the you said
Right.
this,
We
and
set the
this makes
weightage.
sense. Yeah. Like
Okay, I
this
can
makes
see
sense.
why.
It's gibberish.
Yeah,
What you're saying is gibberish, but it's like grammatically
yeah,
correct gibberish. It's like
right,
linguistically correct gibberish, but it's gibberish. We are the beings that will have to tell the GPTs of the world, like, hey, like gibberish.
right. And ooh, that's an interesting. Okay, and how? Okay, so let's say you've got that baseline where it's able to answer questions extremely well, and how do you build on top of that where it's incapable of higher and higher levels of reasoning, and that blows my mind a little because let's say there's a point when your knowledge as a human being cannot successfully confirm or deny the weightage, if you will, of the answer, and how can it do that by itself, if that makes sense?
So what you're asking about is artificial general intelligence.
Yes. Yeah, I was leading up to that as well. Yeah.
So artificial general intelligence is one that is automatically able to figure out something that it has come up with um, how accurate or how correct it is,
Hmm.
irrespective of whether it has seen that in its training data. In
Hmm.
fact, if like if it hasn't seen that in the training data and it has come up with that, that's a pretty good approximation of like this thing is intelligence, right?
Hmm.
So one way that artificial intelligence researchers think about what is a test to give an AGI to check whether it is an AGI or not is, in the training data, remove all mentions of the word consciousness. So this is quite human taxing, like it takes like a lot of effort, but like make sure that the word consciousness is not there. Maybe even go one step further. We're not talking about feasibility, okay? Hypothetically, if we could do this, scrape out all the mentions even of the idea of consciousness.
Hmm.
Okay, so level one is remove all mentions of the word consciousness. Level two is
Hmm.
remove all the mentions of the concept also.
Okay.
Okay,
So it
and
can't
then
conceive of it.
it can't conceive of it, and then like do the training like you normally do, and then
Yeah.
on the other side see if it comes up with the idea of consciousness by itself.
Right.
If it is able to, that is pretty interesting, that it was able to like hallucinate something that
Hmm.
is what we would call true, right?
Right.
But see, the question that you've asked is a speculative question. None of us
Right.
are going to know without like actually AGI coming up. Different
Hmm.
people who are way more educated than me have may have like different ideas. Um, but in my opinion, um, how question is how can you get an AI to automatically understand the value of its own prediction? See, if you take the words A, B, C, D to Z,
Hmm.
okay, they can be combined in literally trillions of ways.
Hmm.
It's just that we as humans have collectively decided that certain configurations make sense and certain don't, right? Like
Hmm.
B, BAT is bat,
Right.
AAT is nothing.
Hmm.
Is that right?
Hmm. Hmm.
The words BAT is bat, which is like a cricket bat, like a
Right. Right. I get
something
it. I
that you
get it.
hit people, take a baseball bat. But AAT is nothing. Why?
Hmm.
That's completely arbitrary. Why is bat meaning that and AAT meaning nothing? It's
Hmm.
because we as humans have collectively agreed that BAT means something and AAT means nothing.
Hmm.
Right?
Hmm.
So, going forward, also, as an AI, the AI is capable, you can think of the AI as being capable of coming up with every combination of a word by using A to Z. Okay?
Right.
How would it know which combinations are useful and which ones are not?
Hmm.
It's not. It requires a human to tell it what combinations are useful and what ones are not, because ultimately it is the humans that are training this AI, and it is humans who the AI needs to be helpful for. Now, don't get
Right.
me wrong, this is not to say that for every single thing a human is required, because if that is the case, then there's no point of artificial intelligence, right? Like for
Hmm.
everything. So,
Hmm.
what the artificial intelligence has been trained on right now is it has been given like lots of valid combinations. And the interesting thing is, if you take those valid combinations and you break them down into smaller pieces, the smallest pieces, and then you combine them up in different ways, it still is valid. For
Hmm.
example, let's take the word defect. Okay, and let's break it down into its subparts. So one part is D, as in DE, and the other part is fect. You could probably even like break the word fect down into smaller parts, but
Mm.
let's not do that for now. Let's just take the word D.
Mm-hmm.
Defect is a word, detest is a word,
Mm-hmm.
okay? Demystify is a word.
Mm-hmm.
Like it's the same component mixed with another valid component that is leading to another new word that is also valid, right?
Right.
So by already giving it valid words or valid combinations and teaching the artificial neural net to automatically understand how to break these down into smaller pieces,
Right.
it is able to figure out like, okay, by breaking them down into these pieces, by combining them up, what you come up with is still valid.
Mm.
So it's like already doing this to a certain extent where it is predicting the quality of its own output. But if it comes up with something that it has never seen before, then you require a human to go in, analyze that, and tell it, yeah, actually, this thing that you've come up with is really interesting. This thing is not. So you could think
Right.
of uh, an intelligence as like a simulator of all possibilities. So it can
Right.
simulate all possibilities, and in all of the possibilities, some really interesting possibilities live and reside. Okay,
Mm-hmm.
but most of the possibilities are, um, I wouldn't say pointless, but they're like they aren't meaningful. They're meaningless possibilities.
Right. Yeah, like I think an interesting like a tangent to this is it's like when the more you read, sometimes you find like pieces of information that you think are relevant but aren't actually relevant to the given like thing you're trying to actually solve, and you might use it to overthink things, or it'll screw up your weightages of how you're judging the
Yeah,
situation,
but that is
and
learning.
that's learning. Mm.
So, like, if you read 20 books, then a thought that you have after that is a logical prediction based on using the context of all of the books that you have read. And you may not remember
Right.
everything in a book, but you remember the central ideas, right? But those
Hmm.
become like the context that you use to formulate the next thought. So that's learning.
Right. Okay, that's actually fascinating. Like because in so many instances, um, you at AI can feel so real in that, but when you look at under the hood, it's just the simplicity of it is kind of beautiful in a way. Like the weightages of it. Maybe I'm just like being a bit reductive here as well, but I'm just when I visualize that, and but what we can do with that simplicity is also astounding. Like
It is
its
right.
ability to like imagine, like I've done it where I've just tried to come up with, let's say if it's two parties, I ask it to come up with an argument and to defend this, and then the complete opposite argument for this. It can do it so freaking well,
Yeah.
and I'm
Yes.
like and yet it's not the sentience we're looking for. It still bases off of human intelligence to the way we've
Yeah.
confirmed or denied. It's
Yeah. But that
fascinating.
intelligence, the way we decide so the first point that you made about it being if you are able to reduce it down to like what a neuron does, like an artificial neuron, it doesn't seem as complicated, right?
Yeah.
It seems almost
Yeah.
simplistic.
Yeah.
But if you do that same thing and you go down the biological rabbit hole to like
Mm.
what a neuron does, more sophisticated, but they do very similar things. Like
Mm.
insanely more sophisticated in the terms of like the complexity that it is able to muster, but like it does the same thing.
Mm.
And the thing about biology and all of these things is, it's like one way of looking at it is it's like a magician revealing their trick, or like a joke being explained. A
Mm.
lot of people think like when you do that, either the joke loses its humor or the
Mm.
magic trick loses its magic.
Mm-hmm.
But what I have found, and that's a very logical and fair thing to think because that's actually true, right? Like when a
Mm.
magician reveals his trick, like the
Yeah.
the awe of it goes away. But with biology and neurons and all of this, I found it to be the opposite, where like the more you peel away, the more you reduce it down to its absolute first principles, the more you're blown away by how those first principles coming together leads to something as complex as us, as complex as like an
Yeah.
artificial intelligence that can reason both sides of an argument.
Hmm.
So like it is like ultimately like
It's
the
like the
only way we can
transistor all
comprehend.
over again.
Yes, yeah. But ultimately, like the human brain has to
Hmm.
reduce to understand. Like we
Right.
cannot, I don't think we can comprehend the continuous. I think it is possible. Maybe like the people who have spent a lot of time um, being spiritual, like doing meditation and all of that, and like really pursued this like with great honesty. I
Hmm.
think they are able to perceive the continuous. But
Hmm.
most of us are able to perceive the world reductively. Like we have to reduce things down to smaller
Hmm.
pieces to understand it. Some people are
Right.
able to reduce it down to the level of atoms. Some people are able to reduce, like are not able to reduce it down to that level, but they're able to reduce it down to like some other aspect. So whatever you're training it.
Hmm.
So for example, you're a designer, right? You probably reduce things down to like their proportions, their symmetry, and like how they like
Hmm.
coexist with each other, their form and their function. So that's your first
Right.
principle. My first
Hmm.
principle, because I think a lot about physics, is like how the atoms and the molecules, like how do they interact. Somebody who studied economics, for them that will be like their this thing, like how does this affect the
Hmm.
humans, how do humans interact with each other. So it's like
Yeah.
ultimately like we reduced based on the central stock of knowledge that we have.
Hmm. And okay, I don't. That's a very fascinating way of how we perceive the world differently based off of what we've studied and how that builds on mental models. And I'm curious, like with the rise of AI, are you see do you see certain mental models or ways of thinking that are just more powerful than others for people that are really looking to leverage this technology?
So there is the way of understanding things at the level of a black box, which is this is what I need to give this thing as an input. This is what it requires as an input.
Hmm.
These are the parameters that I set to it. And I don't care what it is doing inside, but this is what the output is.
Hmm.
Okay. And I'm going to use the output in whatever way that I want to. So
Right.
that's like the highest level of understanding. Uh, the lowest level of understanding, which is you understand thing as one big black box with what is the input and what is the output. The
Hmm.
secondary way of doing that is you take that black box and you try to peer inside, and it's an infinite descent of black boxes. It's like a
Hmm.
Russian Matryoshka doll, like like
Yeah.
doll inside a doll inside a doll.
Yeah.
But when you do that, like you start understanding things more fundamentally. You're like, okay, this is
Hmm.
what it is doing. Fine. Let's take a look inside this black box and uncover the next black box. And then the next
Hmm.
black box, and then the next black box. So at every level that you're increasing your understanding a little bit.
Hmm.
So the second form of learning is a recursive like descent to infinity. Like you will never understand it completely because the universe does not want us to,
Yeah.
because things are chaotic. Chaos like we
Yeah.
cannot understand fully, but
Hmm.
we will always be increasing our understanding.
Hmm.
So one way of thinking about this is that artificial intelligence is kind of like a new raw material.
Hmm.
It didn't exist
Hmm.
before, but it exists now.
Hmm.
Not dissimilar to the internet. So when the internet first came, the internet was a new raw material, it's like a new channel of distribution that emerged.
Hmm.
We didn't know what we were going to do with it, but look at what we've done with it. Like I'm having this
Right.
conversation with you because of that, right?
Right.
So I do think that artificial intelligence has the potential for the same kind of impact.
Hmm.
But it, the right way to think about it is like it's a new form of raw material. Like you start figuring out how can you
Yeah.
use this raw material. Um,
Right.
so I guess like a difference could be um,
Yeah, that's
this
a
just came to my
fascinating
mind. So like
completely agree.
it's like when you first find sand. Sand is a new raw material,
Mm.
right?
Mm-hmm.
You
Right.
find it on the beach.
Mm-hmm.
What are some uses of sand? You
Mm-hmm.
can use it to make earthen pots that you
Mm-hmm.
can fill things with. So that's one
Mm-hmm.
form of using it, right?
Yeah.
If you take the sand and you try to sell sand, you will make some money, but not like a lot of money, right? Because
Mm.
everybody has access to the sand. If you're doing
Mm-hmm.
nothing with it and you're just selling sand, then you're just
Right.
you're capitalizing on the fact that there is sand in your backyard,
Right.
right?
Right.
But if you take that sand and you craft like earthen pots out of it, that
Mm.
increases the value. Not
Right.
everybody is doing that. And now you're able to sell somebody things that they can like fill with water and drink out of. So that's a pretty cool use
Yeah.
case.
Mm.
Let's take it even one step further. Sand is filled with silicon, right?
Mm.
Silica.
Mm.
Silica is the active component of all transistors.
Right.
So, like again, you've taken the same raw material, but you have utilized it to get electrons to move and get transistors to on and off. And now, like you're like making chips that like everybody is using. So that's one way of thinking of it. Okay, so this is a
Mm.
new raw material. Let somebody else take care of creating the raw material, and
Mm-hmm.
I'm going to figure out how to utilize this raw material to extract maximum value. Just
Mm.
selling the raw material is not particularly helpful, which is what I
Right.
think like a majority of the companies that have raised funding right now, that's what they're doing.
Mm.
Like if you
Mm-hmm.
create a tool that is like, I will help you write an email better, I will help you write like an essay better. Like that's just the raw
Right.
material. Like you're literally doing nothing with it. It's as it has come that you're
Mm.
using it, right? Uh,
Right.
some may succeed with that, but like it's not like a sustainable strategy for everybody. Okay, so that's one.
Yeah. It's. Mm-hmm.
The second thing is, okay, now that this raw material exists, do I want to participate in creating the raw material?
Mm.
Okay, and that's a costlier proposition because making the raw material is much harder.
Mm-hmm.
Um, but that's one way of thinking about it. Like, okay, like I will get into like the creation of the raw material. Another way of thinking about like what you could do, like model of thinking is, okay, everybody's going to use raw material. Okay, this new raw material, and they're going to need like if you go into the example of the earthen pots, you're going to need those wheels. Everybody's going to need those wheels to make
Mm.
earthen pots out of.
Yeah.
So like let me get into the business of making earthen pots. It's like selling
Mm.
shovels like
Mm.
for people who are like digging.
Yeah.
So that's another way. So like it's like create the infrastructure that allows
Mm-hmm.
people to run these uh,
Yeah.
large language models, or which is the raw material that we're talking about.
Mm.
So these are like the few ways that there's different ways of thinking about it, but to kind of give you like an overarching like way that I'm thinking about it, and I usually think history is the best predictor of the future, and um, in history things don't repeat, but they do rhyme. So finding other things that could potentially rhyme is like an interesting way of looking at things. So
Right.
when the iPhone first came out and when it launched the App Store, um, lots of apps made money. Some of these apps were, like fart apps, like the ones that make some sound. There's a
Mm-hmm.
few apps that literally you pay $999 just for the elite privilege of having a certain app. So
Yeah.
initially, like a lot of these apps were not particularly functional. Even the games were fairly like simplistic. but they all made money. Some of them even raised money. The reason was
Mm.
because the iPhone was a completely new distribution channel. It's kind of like a new raw material,
Mm.
analogously. And because a new raw material was discovered, because a new distribution channel was discovered, like anything you do, you will make some money because it's brand new.
Mm. Right.
But over time, uh, these businesses didn't succeed. The
Mm.
first few businesses that succeeded by using the iPhone App Store as like a proper platform, I would say were like Uber, Snapchat,
Mm-hmm. Mm-hmm.
Facebook Mobile. Like these are some of the first Instagram. Like these are some of the
Mm.
first apps that were built on that platform that truly utilized its potential, right?
Mm.
So I think the same is going to happen with artificial intelligence. Like artificial intelligence is a new distribution channel. It's a new like raw material. There is incredibly innovative ways of like utilizing it to like create incredible things. Like who thought that you could use sand and silica to like make fucking computers? Like that's insane, right? So
Right.
the same kind of possibility is embedded in artificial intelligence. What it is going to be is is like your innovation, is your creativity. Like if you're creative
Mm.
enough and like you were able to do something interesting enough which solves a real world human problem, where you're not just using AI for the sake of using AI, but like you're solving a real world human problem, then you will win.
Mm. And do you see like any ideas that are in the space that are worthy of that title?
Yeah, there's like a few companies that have like raised like good money and are doing interesting things. Um, so there's one called Harvey, which is
Mm.
AI for legal.
Hmm.
So the legal industry is like very text heavy, right? So
Mm-hmm.
having something like this to help out is a very cool idea. And like the reason that
Mm.
lawyers charge so much money is because at the end of the day they need a human to go through each one of these lines on like 300-page long contracts and like underline everything and like like it's a lot of work and AI can really help there.
Right.
So I think Harvey is a really interesting company. Um, there is a company called 11 Labs that very recently raised money. They're
Mm-hmm.
using AI to generate synthetic voices that sound incredibly human like.
Mm-hmm.
And when I say incredibly human like, it means like it contains the intonations, the ups, the
Mm.
downs, the pauses, the ums, that make us sound human. Like we don't even think about it, but if you hear a computer voice, like you're very quickly able to tell that okay, this is not a human, right?
Mm-hmm.
11 Labs, I came up with like technology that allows it to create incredibly real sounding human voices.
Mm-hmm.
Um, there's a few big ones like Jasper and Writer. These are utilizing large language models to help companies to copywriting.
Mm. And like going on the highest level, which is when you're building the raw material front, like Bard and Chat GPT, do you see one winning over the other, like Bard versus Chat GPT, and or other players in the space? I don't know. I don't think there are any others that are worthy of that level, at least right, not yet. Um, and
There are there are a few other players that are also doing really interesting things. There's one called Anthropic. There's one called Cohere.
Mhm.
Um, but to the meta question of is there a winning strategy or is there a winner?
Yeah. Or will there be?
Potentially, I feel like it's not dissimilar to the operating system war.
Hmm.
So in the end, when operating systems first came out, there was many flavors of it, if I'm not mistaken. But the ones that won in the end were Windows and Macintosh and Linux.
Mm-hmm.
So Windows and Macintosh were like the duopoly, that
Mm-hmm.
rules like the private consumer market.
Mm-hmm.
Linux is for the developers and the hobby market. I
Mm-hmm.
think some flavor of those three will win out in the end. So today, if somebody came up to you and told you that they're innovating with a completely new operating system, you'd be like, okay, that's cool, but that's a pretty solved problem. It's
Right.
not like it's a solved problem, but like companies like Microsoft and Mac, like Apple have been doing it for like 30, 40 years at this point, right?
Mm-hmm.
So they have
Right.
incredible advantages. They have incredible data on like how things are working. So they have a clear advantage.
Mm-hmm.
So it doesn't make too much sense to innovate on that. Just leave that innovation to them. So I think
Mm-hmm.
something similar may happen in artificial intelligence, but I'm not sure. This is all again very speculative because artificial intelligence ultimately the data that it is trained on, if you think about it, is available to all of us.
Mm-hmm.
So most of the data is open source. Sure, OpenAI and like these companies, these big companies, they have some back-end deals with publishing companies, which gives them access to proprietary data that others may not have. But I think that forms like a small percent of the overall training set. For most intents and purposes, like about 95% or 90% of the data that they have used, I could literally download right now. Like literally,
Mm-hmm.
like right now, I could go and download,
Mm-hmm.
and it is available in a clean form. Like I don't have to like
Mm.
scrape the internet or something. It's like already been scraped and like stored in a data set that anybody can use.
Right.
What differentiates whether a model is useful or not is how much compute do you throw at it,
Mm-hmm.
and compute is very expensive. So, as an
Right.
example, the training of GPT-4 costed about $100 million.
Mm-hmm.
Just the training. It's
Damn.
quite insane. It's almost
Mm-hmm.
like $1 million worth of GPU training every day
Mm-hmm.
for like 100 days. So that's
Mm-hmm.
very large amounts of money, right? Like I'm not going to
Right.
be able to muster that kind of money.
Mm.
But this is also true like of the first operating systems. Like the first operating systems like were built to run on really large mainframe computers, but today they run on a
Mm.
personal computer just fine,
Right.
right?
Mm.
So
Yeah.
over time, the cost of training your own artificial intelligence model will go down,
Right. Hmm.
and how different companies respond to that would be interesting.
Right.
So OpenAI likely is going to be like the Macintosh of like large language models. It's
Mm.
highest quality but very less control. Like you do not get to peek under the hood. You do not get to like see what is happening or what they're doing, what the architecture is. You just get
Mm.
to use the fully finished product, and it's a great
Mm.
product.
Right.
But if you want to do anything with it, like beyond the use cases that they have defined, then good luck. Whereas
Right.
other models will be more open on that front, so they'll be more hackable, so to say. So I feel like that is how like these different models will start differentiating themselves. Some will be more hackable, somebody will be more like this is what you get, like use it or go away.
Gotcha. And in the big giants then like Bard versus ChatGPT, do you think the data will could be a differentiating factor, even if it's the 5% between these models, or like do you see another element that I'm not fully seeing here that could really give one AI an edge over the other?
I think yes, the data is going to play some difference, but not to the extent that this is going to win and the other one is not.
Hmm.
I think there's a subfield of artificial intelligence called alignment,
Hmm.
which is while this is a universal simulator, we talked about how you can think of an intelligence as being essentially able to simulate all possibilities. out of those, a few possibilities are interesting, and even fewer set of possibilities are relevant to us as humans,
Mm-hmm.
right? So, how do you train this system over time to keep finding those ones that are most relevant to us, most useful to us?
Mm-hmm.
So, simpler way of saying this is, how do you ground the system in truth?
Mm-hmm.
So, Chat GPT, for example, like if you compare Bard versus Chat GPT and Bing, just same as Chat GPT, for creative inputs, for like creative queries, like
Mm-hmm.
act like this and argue this side, become an interviewer and speak to me about, like, interview me about this, like for those kinds of creative things, Chat GPT and Bing Chat are better.
Mm-hmm.
But for things where you need things to be factual, where you need the answers to be grounded in the truth, Bard is better.
Right.
So
Hmm.
that becomes another level, that another dimension that these two will like differentiate themselves. One might choose to go down the more creative, like I will help the creative people path, and the other could be more
Mm.
factual based.
Right.
So that's another way that they may differentiate themselves. Another way is, some of them may allow, and Facebook is kind of trying to do this, which is, um, they are going to train a model and they're going to open source
Mm-hmm.
it. And
Mm-hmm.
then you can use their open source model and do whatever you want. So that's the very hackable model.
Mm-hmm.
And what they will then do is, um, I'll just do the central training. You get to utilize it however you see fit. So I don't have as much control over what
Mm-hmm.
you're utilizing it, how you're breaking it apart. Like it's like
Mm-hmm.
selling somebody a computer and like you're opening the screws up and like taking the parts out and mixing them up in specific ways.
Mm-hmm.
So that's another way.
Hmm. Mm. Okay, that's quite interesting. So, like, it's really the what they choose to put weightages on or double down on. Let's say, like, creatively, in terms of reasoning. Like, I can see that in Harvey, for instance.
Yeah.
Um, and I wonder if they can do it all. I guess that time will tell about that one. I'm curious as well. Like, why is a model like Midjourney way better than Dali?
Hmm. So a similar analogy applies here. So Midjourney you could think of as the Macintosh of computers.
Right.
uh,
Mm-hmm.
Dalle as the Windows, and Stable Diffusion
Mm-hmm.
as the Linux.
Mm-hmm.
So Midjourney has been trained on aesthetically pleasing images. Like it has been trained to
Mm.
output more aesthetically pleasing images.
Right.
So that's why like the outputs of Midjourney are more aesthetically pleasing, whereas Dalle may not be trained on aesthetically pleasing images, but like real images. So
Mm.
most of these models, like you could argue about compute and all of this, but the single known way of making these models better, a short way of making these models better, is by introducing new data.
Mm.
The problem with large language models is like we are getting pretty close to consuming everything that humans have ever created. Can you
Mm.
believe that? All of the data
That's
that
mad.
we've ever created, we're almost on the verge of consuming. So if we need more data now, it's like incestuous, because it's like the AI is generating the data that it is then feeding itself on.
Right.
So you see how like very
It's
similar
crazy.
to how like siblings getting married, or like like those kinds of things. Like the biases become
Mm.
worse,
Right. Right.
but it'll take time. It'll take time.
Uh-huh.
So with Midjourney and all of these things, they have selected data. I believe, I haven't like really studied this, but like I believe they have selected the data where the outputs are aesthetically pleasing. Or
Mm-hmm.
they maybe likely started with like a very similar model to Dali, but
Mm-hmm.
they fine tuned on top of that to make it output more aesthetically pleasing images.
Gotcha.
And Dali is unfine tuned, it's just as it is.
Mm-hmm. Okay.
So that's likely why like the images of Midjourney are like way more aesthetic. And I agree with you. They're like way more aesthetically pleasing.
But why is this technology like moving like developing so quickly? Uh, it's like 1 minute you're seeing Chat GPT one, and then we're already on the fourth version of it. And how is it able to develop at such a speed? I don't remember the internet ever doing this.
It was though, right? Like
Not
you
at.
remember
It's
the
even
dot
faster
com.
than the internet, or faster.
Yeah, but it's like there's a video that I recommend to a lot of people. It's titled "The Single Most Important Video That You Will Ever See." I think that's literally the title of it on YouTube, and it goes
Hmm.
into how the biggest one of the biggest deficiencies of the human brain is its inability to understand compound growth.
Mm-hmm. Hmm.
So with compound growth, initially the progress seems very slow, and then suddenly, like what seems like very short period of time, all of the previous growth kind of like compounds on itself, and then like you see that familiar hockey stick
Mm-hmm.
growth.
Yeah, yeah.
So AI as a thing was first coined by a group of people who met at Dartmouth University. Okay,
Mm.
off in this group there was like people like Marvin Minsky, um, a few other people that are alive even today, but like that's the person I remember.
Mm.
They met in I think the 1960s or something like that, or maybe
Mm.
even yeah, I think 1960s. And they got together.
Mm.
They were like forward-thinking computer scientists, and they
Mm.
realized the possibility of an artificial intelligence. We did not have
Mm.
the compute capacity to even build something like that,
Right.
but they envisioned that this could be possible. So that's
Right.
like when artificial intelligence as a term was coined, and it went through few cycles of like ups and downs. So like there was a period of the AI summer where like lots like when they first came up with the terminology and like they set out what an AI could do, everybody was really interested because like who wouldn't be, right?
Mm.
And so like a lot of the US government gave them funding, national science grant, like NSF
Mm.
grants came in to like help them, and that kind of got them the initial funding to develop certain things, develop certain algorithms, develop certain ideas. But then
Mm.
after that happened for like 10, 15, 20 years, the funding dried up because the promises that they made were not achieved because it couldn't be because the computing capacity and everything was not there. So then AI went through an AI winter. Then again,
Mm.
after 10, 20 years, it goes through an AI summer. Again, it goes through a
Mm.
winter, right? So it's this
Mm.
cycle. So what you're seeing is like, why is it growing so suddenly?
Mm.
People have been working on this for the last 50, 60 years.
Mm.
And it is now that all of the things that are required for it to succeed have kind of come together.
Mm. I see.
So, like the compute capacity, the algorithms, the architectures, like all of those things have come together. So the fundamental blocks are now in place to
Mm.
um, to enable the that upward this thing. So to more directly answer your question, two big things are contributing towards this like massive like change. One, or actually three things. One, compute capacity has blown out. So like we now have access to compute like GPUs and like really fast CPUs that we just never had access to before. These things are
Mm-hmm.
able to do like teraflop calculations, which means a
Mm.
teraflop is 1 tera, which is 10 power 12 calculations per second, which is insane.
Mm.
So
Mm.
that's one. And we're utilizing the full power of that for training these nets. Okay, that's number one.
Mm.
Number two, the architecture. In 2017, a paper came out from Google. that set out the architecture for this thing called a transformer. So we talked about
Mm-hmm.
how these modern neural nets are able to figure out what part of a sequence to pay attention to more versus to another which they
Mm.
should pay less attention to, right? So in some ways this system has been taught how to value certain sequences, like what to pay attention to and what not to. And
Mm.
that came out in this paper. So this paper, it's literally titled "Attention is All You Need." So they implemented a fundamental architecture that is able to figure out by itself what to pay attention to and what not to. And
Mm.
that paper is responsible for all the modern architectures. All of the modern architectures
Mm.
are transformer based architectures. That single paper is what
Mm.
I would say led to the revolution in artificial intelligence. That's number two.
Mm.
Number three, because artificial intelligence is so buzzy right now, everybody's working on it. And when like a
Mm.
large
Yeah.
cross section of humans are working on something, obviously they're going to cross pollinate ideas, right? And like there's going to
Mm-hmm.
lead to more things happening.
Yeah,
So all of
exactly.
these three things coming together has led to like the crazy, crazy growth. But it may look like really, really crazy growth. But if you understand enough about these things and you read through these things with understanding, the central ideas are fairly similar. There aren't like
Mm.
fundamentally groundbreakingly new ideas. It's just interesting combinations of the letters. You know, like we have A to Z,
Right.
like we're just combining them,
Right.
right? So
Right.
nobody's introducing a new letter. The new letter was
Mm.
like the introduction of that paper, the transformer paper in 2017.
Yeah.
After that, you're just
Mm.
using those pieces and you're mixing them up in interesting ways, and
Mm.
like interesting things are coming out. That's
I
where a
see.
lot of these
They're
papers are.
utilizing the raw material, but this is just like the first layer of that, and we yet to see those bigger shifts in the space.
Yeah, yeah.
But with the way it's going, and I think it can come fast. And do you see any potential risk associated with the rapid development of artificial intelligence?
Yes, there are risks. The
Do you have any
risks
predictions?
are the risks are around what does a human being with a lot of power and whose interests are not aligned with humanity, or in fact
Hmm.
are opposite in alignment to humanities,
Hmm.
gets access to a really powerful AI.
Hmm.
Because ultimately, it still requires a human being to like do the things that an AI has set out to do,
Hmm.
um, or less what it sets out or what it says. So one big risk is a bad actor getting access to really powerful AI.
Hmm.
Okay, I don't think we're like, right there. I don't think we're there right now. It's like quite some time, quite a while in the future, I think, speculatively.
Hmm.
But that's one risk. Another risk is that there's companies like Boston Dynamics, which I don't know whether you've seen those really scary looking robo dogs that like dance to videos.
Yeah,
Have you
it's
seen those?
crazy.
It
Yeah.
looks so freaking scary, right? Like they could literally kill you if like they're given that instruction,
If they can dance, they can probably kill you.
right?
Yeah.
So if those get equipped with artificial intelligence and like
Hmm.
really advanced artificial, we're not there yet. Right now, the artificial intelligence is only able to deal with the symbolic universe, and that to the symbolic universe that it has been fed by a human. For
Hmm. Hmm.
real AGI, the system, the robot dog or the robot should be able to build its own symbolic universe by just
Hmm.
existing in the world,
Hmm. Hmm.
because that's what we
Its
do,
own
right?
language.
Yeah, its own language. It's like, no, see, thing is like it's not like its own language. Yes, it's its own language, but like the beauty is that we converge to a very similar relative language. So
Hmm.
you've lived a completely different life than mine,
Hmm.
right? Um,
Hmm.
But you have language is how you organize your world. Language is
Hmm.
how I organize my world. My world is very different from your world, but it is relatively
Hmm.
similar enough that we can communicate.
Hmm.
So it is like converging also to the most optimal symbolic representation that everybody converges to.
Hmm.
If you
Right.
just converge to like your own symbolic representation that makes only sense to you, it's like you're keep speaking a completely foreign language and I'm speaking completely foreign language. What's the point of communication? Because we will never understand each other. But we have converged
Yeah.
to a common language. So these
Hmm.
systems, if they are embedded with an AI that can formulate its own symbolic language, that would be truly conscious.
Hmm.
That like gets into like those like really scary, but like also quite possibly like that is the future where like
Hmm.
biological intelligence will coexist with artificial intelligence, and we
Hmm.
will live in a classist society where for no reason biological
Hmm.
intelligence is of higher value
Hmm.
and artificial intelligence is of a lower value. So that possibility exists. But the true beauty of the biological intelligence is that we are able to zoom into the smallest probability and expand that out.
Hmm.
What I mean by that is, let's say you were an intelligence that has been put on planet Earth and you're asked to differentiate between living and non living.
Hmm.
Okay? And you are able to, at a first guess and first approximation, realize that, okay, living could be things that move by themselves,
Hmm.
they autonomously move.
Hmm.
You could stop there. But we take
Hmm.
it even further. We're like, okay, of the things
Hmm.
that are alive now, now that we've decided that, how do we further
Hmm.
differentiate? Okay,
Hmm.
what are terrestrial, what are aquatic? Okay, what is the
Hmm.
difference in there? So it's like we have the capability to recursively keep going down in complexity,
Hmm.
and that is a never ending spiral.
Hmm.
Will an artificial intelligence be able to go down a never ending spiral? I don't know. But I do know that an artificial intelligence will always be able to go at least as far as a human being has been able to, and
Hmm.
better than a human has been able to. But
Hmm.
it likely may not be able to go further. The going further will be
Hmm.
biologically directed.
Yeah, and I'm curious, like the very fact that human beings are able to conceive of such things. Um, I wonder if it can do so as well, and with the way it can compute information and understand it. I wonder if can they be able to do that eventually. Well, because if you have the sum of human intelligence and everything that's wrong with it, and then also able to reason, let's see. I mean, only time will tell that question, right? Hmm?
But like you can apply the same to human intelligence also, right? Like Thomas Kuhn talked famously about like in a book that he wrote about paradigm changes. Certain
Hmm.
people come up with certain ideas that change the paradigm.
Right.
Up until then, everybody who was working before that are utilizing those same ideas
Hmm.
and mixing and matching them in different ways.
Right.
But like a paradigm shifting idea is not a logical output of all of the previous. In
Hmm.
fact, it is like opposite to that.
Hmm.
So, like Albert Einstein coming up with the idea for a theory of relativity is
Hmm.
completely in opposition to like Isaac Newton's idea of
Hmm.
like classical mechanics. Like
Hmm.
just because humans had all of the previous knowledge up until that point,
Right.
theory of
But
relativity coming
novelty.
is not in that. So
Hmm.
somehow, even though you had access to that, we like took a step up. But then
Hmm.
after, like, so between Isaac Newton came up with his idea and Einstein came up with theory of relativity, the people who were working in that realm of physics were like doing interesting things. Don't get me wrong, but they were like
Right.
not fundamentally new ideas. They were finding incredibly interesting engineering use cases. So like using the ideas to build things, but like not fundamentally new ideas. So
Right. Right.
what is it about biological intelligence that enables those paradigm shifting ideas? Like coming up with quantum mechanics. Like how do you come up with an idea which essentially breaks your brain? Like to think that you keep reducing things down further and further and further, and what you're left with is little packets of probability. Like
Mm,
how did you even decide that of the realm of possibilities that's like interesting, and let's like hold on to that one, like.
mm,
So those paradigm shifting ideas, I do think, show us that there is something that we do that is
mm,
outside. It's almost like we are able to comprehend chaos just a little
mm,
bit. And every
mm,
time we do that, few people are able to do that. You're able to just like take one step further. And once you take that one step further, then once you take that step further, then artificial intelligence will be able to do likely what you're doing as better than
yeah.
humans, because
It.
it's able to consume all knowledge.
Yeah, but it can't push the needle yet.
That's what
Right.
I think. That's what I
Yeah.
think. I don't know whether it will ever be able to,
Hmm. Very
but that's my
interesting.
controversial opinion.
Fair enough. One down, 20 to go. Okay. Um, and this is fascinating. And do you see any ways of mitigating the risks you mentioned about bad actors and the bad actors, and what was the other one? Sorry.
Bad actors and like uh, a humanoid robot like being embedded with like being
Yeah.
able to input your own symbolic universe.
Mm-hmm.
I don't think the second is really a risk. I feel like it's inevitably going to happen. I
Okay.
think the
This.
first place that may happen is the metaverse, because the metaverse is essentially like a symbolic representation of the real universe. And
Ooh.
so like you get things there, and like you get them to play with each other, and like.
Another reason not to trust Facebook.
No, Facebook is like in the world of like AI. Facebook is actually the good actor, believe it or not. Like they're like open sourcing their models and
Really?
letting people play with it.
Ah,
Yeah,
yeah.
it's kind of interesting.
Getting
Um,
back that equity they lost.
yeah, I don't know.
Mm, mm,
I'm not the best person because I'm an optimist,
mm.
and an optimist is not the best person to think about all the way things could go wrong.
Fair enough.
But
And yeah,
the way that OpenAI wants you to think about it is they want you to regulate this industry. Okay?
yeah.
And they want to regulate it because likely they understand that in the long term they do not have a competitive like data, like they don't have a competitive advantage. Like if GPU costs keep getting cheaper and cheaper, open source models will start winning. So by
Mm,
regulating the industry, they are getting to set the rules
mm.
that others have to follow
Ooh,
to win. So that's like it's a great business strategy. If you think about it, it's a
it
great business
is.
strategy.
Yeah, especially the way they've done it. It's just like it's when I saw the Congress hearing, I was very confused when he said that because it's like, wait, is this like a Trojan horse?
Right? Like, why
It
would you want
does
to
feel
regulate your
like that.
industry? Yeah,
Yeah.
because they know that it has to be regulated at a certain point. They're like, why don't
Hmm.
we just set the precedent and like make it so that it's incredibly conducive to us and only
Hmm.
us,
Hmm.
right? So regulation does sound like the easy answer, but there is like a lot of nuance there as well.
Hmm.
Um,
How will they regulate this technology at all?
Apparently, what OpenAI wants people to do is what wants the government to do is to like control the number of people who are training their own artificial intelligences. But they
I don't
get to
understand.
because but they get
Yeah.
to because like they wrote the rules, right?
Yeah. It's like like Congress just passes a law. Just less OpenAI is not included in this bracket.
Yeah, but a few ways. Okay, now that
Hmm.
you asked the question, I'm thinking about. So the way. that you test an artificial intelligence is through evaluations. Um, because let's say I come up with something like a GPT-3, GPT-4. How do I know it is actually doing something interesting? Right? You need
Mm.
some test for it to be able to, for me to be able to uniformly say, like, I can put this model on that test, I can put another model on the same test, another model on the same test, and see how they score, and like based on that I should be able to tell, right?
Mm.
So there's different kinds of evaluation benchmarks. There's something called,
Mm.
I think, Vinograd or something, where in certain sentences where the pronoun is ambiguous by the
Mm.
rules of language, can an artificial, like a human can tell it because of how we understand it, can
Mm.
an AI
Mm.
disambiguate if like the word it means this or that? So that's like,
That's interesting.
so that's an example of an evaluation. There's like many evaluations like that. Some evaluations
Mm.
are like uh, logical yes nos. Another is like there's a test that it has to like pass. You know, like, so these are various
Mm.
evaluations.
Mm.
Um, Most of the GPT-4s, like when they publish the results, they are essentially publishing the results of the benchmark. Like on the
Mm.
BLEU score, like we scored this much versus everybody else scored only this much. So the
Mm.
benchmarks is how you test your model. So maybe one way of doing it is that the government or some central body creates a centralized set of evaluation models that every neural net needs to go through.
Mm. Mm.
So this is not dissimilar to the human biology, where we have immune cells. Immune cells are incredibly powerful. If the immune
Mm.
cells were left to kind of do their thing and like the control was reduced, they would kill you. They're that powerful. And one of the ways they do that is through uh, B cells, where they're created in the bone marrow. And what
Mm.
happens is a new cell is created by shuffling together like the genetic code a little bit. Okay, and
Right.
then it kind of goes through like a equivalent of a school where it is trained to pick out invaders. Okay, that's what the genetic recombination is for. Like, are you able to pick out invaders?
Mm.
But in doing this combination, the combination is random, right? There is a chance that you will recognize as an invader your own body cell.
Mm.
And if it does that, if it starts attacking your own body, it's what we call an autoimmune disease. So the
Right.
way that what happens is when it goes through this like conceptual school, um, gets created and then it's tested with various body cells. Like, are you reacting to your own body cells? You are, kill. Only the
Right.
ones that are do not recognize your own body cells are allowed to graduate, because the invaders
Mm.
will have a different type. So in a similar way,
Right.
if a government comes up with like an evaluation system which
Mm.
essentially is able to teach the AI to differentiate between self and like, so like good or bad, what, it's like very subjective thing, but I do think it's possible. And every model that gets trained, like you have
Mm.
to, this has to go through this like test, and if it fails that
Mm.
test, it gets killed.
Right. Interesting.
So
I'm curious,
like
like, what
that
the
could be a
model would
way.
look out for.
Yeah,
So,
so this is
just to
like
understand,
purely
like,
subjective.
oh shit. Yeah. Hello. My internet
Yeah,
cut
yeah,
out.
okay.
India. Jai Hind. But like, oh man, that's so. Understanding that though. So let's say like what would it look out for? That was the question. What would it look out for?
I don't know. That's like purely like
Speculative.
not speculative. I do think that that's a good method, but I don't know what the test would include. Maybe something like
Yeah.
the three laws of Asimov's robotics. You know, you cannot harm another human. You cannot, by inaction, let a human come to harm. and you cannot even at the directive of a human, like kill
Yeah.
yourself, and that's the order of the
Yeah.
laws, right? Maybe some equivalent version of that tested out in like an evaluation benchmark where you give it a test and you ask it to
Hmm.
like output like what would you do in this scenario, and if it says I would kill the human, that's like a negative mark against it. So like you
Yeah.
come,
It's
you
it's
get what the
it's
score is,
literally like it's
like the
literally
killing
like
intent score.
yeah. It's like the American judiciary system, like to the criminal justice system. It's like just like a bunch of people get in there, like that
Wait,
should
but that's
not
not a
be
bad
there.
idea. But that's not a bad idea at all. Like, get this
What, to
thing
incarcerate
to
people?
pass
Oh,
through
sorry.
a judicial, like the stuff that we've come up with constitutionally, that should be the
Hmm.
law that the AI also follows.
Hmm. It's interesting that because it's such a new space as well, we can't fully know what would like what would a crime be in this case, like, to continue that analogy. Even biology has only learned through evolution, and even it still screws up,
Yeah,
as is the case with
yeah,
autoimmune disease.
yeah, yeah.
Very complicated question. I'm curious, like, if there's any like hardware or other parameters that doesn't rely so much on reason, or like evaluating the AI's ability to sort of harm humanity. That are more, let's say, in the line of the raw material space. Like, how can if something on that front can be regulated, if it can.
Hmm. But
I think the
that
weightages might be
little
a
bit kind of, huh?
I think the weightages might be a possibility there. Like where the way,
No,
if
the
I don't know if you
weightages
can
are
conceive of
really
them because
hard.
we don't exactly. Hmm. But yeah, like
It's like
your
there
thoughts
are
on that?
trillion weights. Like, how many are you going to like
Yeah.
control? But the equivalent, so the question that you asked is not dissimilar from saying the hardware question that somebody has access to the chipset on your phone.
Mm-hmm.
The phone, which you consider an extension of yourself, if somebody can
Mm.
go in and switch it off based on some arbitrary way that they have decided to use to judge whether you
Mm.
are using it well or not, they
Yeah.
can just come in and like randomly shut it off and you have no control over it. That's not really
Exactly.
fun, right?
Yeah. In
So
such an early
I don't
degree.
know, but yes, that is a possibility. It's like what you're saying is, can we have a backdoor in every hardware chip that gets
Mm.
utilized to run inference on neural models, neural nets?
Mm. All right. And I guess worst case scenario, let's say we wanted to blow up this technology, that particular AI. I don't see it going any other way. If you like, if this to shut it down, like I think having that capability is very necessary.
Hmm. Hmm.
Hmm. Do you think that?
Yeah, I don't know. I feel like when you try to control progress, you make it's not a like a lot of our progress has been possible because we make things open and free for people to experiment with, play with. If you start
Hmm.
adding restrictions,
Yeah.
but then look, like we have restrictions around purchase of weapons. So like, clearly this is not like an
Only
all
the Americans.
like every single yeah. But like clearly like like there are exceptions. So right, certain things
Hmm.
need to be regulated. Like, for
Hmm.
example, acid needs to be regulated in India.
Hmm.
Like when I say acid, I mean not LSD, but like H2SO4, because
Hmm.
or hydrochloric acid, because number of like acid, like
Yeah.
when
Attacks. Ugh.
you know what I'm talking about, right? Like people throw acid on
Yeah.
people's faces and like scarring them for life just because they
Hmm.
rejected their advances or something like that. So like
Yeah.
different things need to be regulated. So like I to think that it's a very nuanced question. Like there's not going to be a clear answer of like it's this or that.
Yeah, fair. The I think the right now we're in such an early stage that speculation is how we eventually figure out the end. Like that
Yeah, yeah,
speculation will become
I agree.
concrete. Like even your take on OpenAI and why they're pushing this legislation. That is a very interesting take that I haven't heard before. And even like and looking at it from OpenAI's perspective as well, like it's such a good PR. like oh, we are an ethical
Yeah, it's
company.
great PR. It's a great business strategy as well.
Exactly. Like it's like if Facebook did it the right way. uh, maybe that's maybe a crude analogy, but I can
Yeah,
see it happening. And do you
yeah.
think that um, the way the AI is an object of moral concern. Like, should we think about like how we're talking to the AI? Should we be worried like it's gonna murder our families?
Should you worry whether it's going to murder us?
Nah, I'm kidding. Like, but like, should we worry about like how we should talk to it?
Yeah, no, no, but that's a fair question. That's a fair question.
It is.
Um,
uh,
it's ultimately our most base biological drive is to survive, right?
mm-hmm.
Are we inadvertently making something that affects that biological drive?
Hmm.
I don't know. Um, I do think that artificial intelligence is going to be in service of humanity rather than exceed us. I think at some point, at the level of complexity that an artificial intelligence can uh, can like be is going to be approximately at the same level, but in a slightly different way to
Mm-hmm.
what a human being is able to do.
Mm-hmm.
So that's like the high, it's like like the idea is like even with all of our intelligence,
Mm-hmm.
we cannot imagine something that is more complicated than us.
Right.
Everything that we imagine that is more complicated than us is us, just with like some random
Yeah.
superpowers, like person can fly, can throw lightning, like that's
Yeah.
it's a very simplistic way of thinking of something that is like better. Like could an ape have thought
Mm-hmm.
about something more complicated than it, which is a human? Could an ape have
Mm-hmm.
imagined a human? I don't think so. It's so
Mm-hmm.
outside its realm, right?
Mm-hmm.
So I do think that higher and higher forms of intelligence is mostly possible only through evolution in the natural world.
Mm-hmm.
And intelligence is able to create something
Mm-hmm.
which is at the most as intelligent as itself, not more.
Hmm.
And like the AI, the benefit that it has is it is trained on all the knowledge that human beings have ever created, right? It's not
Right.
so you and me, like we have like a smaller set of information to deal like to use.
Mm-hmm. Mm-hmm.
But we utilize that information really, really efficiently. Whereas like AI is like pretty inefficient. Like it needs to know everything about everything to even have like a thought.
Everything. It's a simulate the living shit out of it.
Yeah, yeah,
Yeah.
yeah.
Mm.
So
Mm. But,
I don't know. The question was like, are you should we be afraid that it may kill us? Yes, it doesn't harm to keep considering that because it's like one of those things. Like if you don't consider it and it happens, then it's already too late,
mm-hmm.
right? So it doesn't harm to think about it, but I do think that this idea that an intelligence like AI will create another AI that will be better than itself and then better than itself and that will continue up to like infinity, I think is I don't fully buy into that argument. In fact, like I don't know whether biological intelligence is fully computational. I think there is
Mm,
lots of computational elements, not computations, whether it is completely algorithmic. So like there's
mm,
definitely parts of it that are very algorithmic, but
mm,
I think we do something outside of algorithms, which is what enables us to have these paradigm changing ideas. Not every human being, but some.
mm.
So
I agree.
yeah. So my fundamental belief is an intelligence is only able to create something that is as intelligence as itself, not more. No matter
Mm,
how artificial, how genius intellect you are. Um,
mhm,
but in the symbolic universe, we can play pretty high, like keep creating new ideas. And I do think that responsibility still falls on humans, and then AI
mhm,
is going to be an incredible help to humans to the point of
mhm,
having equal status.
mhm.
I don't know if it's like going to come in and kill. When I say I'm not going to kill, like human beings also kill,
All right.
right? So like it's not like it's never going to do it. Certain
Mhm,
mutations, certain mutants, certain like errors
mhm.
may cause it to do it, but it's going to be the exception rather than the norm.
And that wraps up another episode. I hope you liked it. And if you did, do consider subscribing and leaving a like. You can find the links to Anudeep and everything that we've talked about in the show notes below. And yeah, have a good one.